It's time to kick ass and chew bubble gum. And I'm all out of gum.
You gotta take big chances in order for the potential for a big positive outcome.
Oh boy, we're gonna have a swell time tonight.
Winner, Sheen dinner.
Hello, welcome back to A Boring Revolution, your number one news source for all information regarding the Boring Company. Today's episode is going to be an interesting one because we want to talk about an interesting startup that's attempting to do something very similar to the Boring Company, but in a very different, very unique way. I find it fascinating. A lot of people have reached out to me and said, hey, please talk about this company. What's even better is this is a British company. The founder has very strong links to the oil and gas industry, more specifically drilling for oil and gas. And some of that knowledge and expertise and technology has been implemented into this company, which is great to see that transition of kind of technology going from an industry that's essentially going to die in the next 15 years to a new burgeoning industry that potentially could be massively expanding. And I wanted to talk to you about the technology. So let me prep the video and we can get going.
The process begins by drilling a central index bore using horizontal directional drilling. This provides a core sample. Shape are added, giving access for our survey tools to gather data for the digital twin. Semi-autonomous robots are delivered on site and sent into the lined construction bores. Hundreds or thousands of them act as a swarm, working throughout the system, all at the same time.
So these robots in themselves are quite fascinating. So as you can see, they operate in these smaller tunnels that kind of surround the circumference of the actual tunnel, and they're like a semicircle. They operate in these casings. I'm not sure what these casings are made out of. They seem extremely thick, almost too thick to be steel. They might be some kind of composite material, but then they kind of act autonomously in various lengths of the tunnel. So you might have one of these robots every sort of 10 meters of tunnel, and it comes in and comes out. It looks like it's battery powered. It looks like all the materials that are needed are stored within the machine, which, given that this is probably about 14, 15, maybe 16 inch in diameter, that is quite a small space to have all your materials in there. So ultimately it's going to be entering and leaving the system at multiple occasions throughout the day.
The bots are designed to pass each other inside the pipe, so they can work with maximum efficiency. They move freely to locations to carry out their set tasks, such as surveying and installing controlled access points into the geology. A CNC-controlled robot arm carves precise chambers in the geology.
See, now this, I'll start with this. I like the idea, but straight away, this visualization is just, I'm not really feeling it too much, because they've got these kind of, I don't know what you call them, kind of like wishbone, kind of like interlocking segments. And it's like, how are these segments formed prior to you then excavating this chamber with this CNC machine? Like, how is that a flat surface? Because they do this by injecting grout into the strata. Now, if you probably watch this channel, you've seen me raving about grouting an area, like stabilizing the ground. But there are inherent issues with grouting, in that you need to inject a hell of a lot of grout to kind of stabilize, poor kind of ground conditions. Which is all well and good when you've got like a kind of a consistent sand like you've got here, but when you do inject that grout, there's obviously like a curing time, so you've got 6 to 10 days to wait for that to dry out. You've got a wet process, which again it is adding to the time of construction. And when you inject that grout, it's going to be like a bubble, like a sphere. How is it going to form these smooth, flat surfaces like this, like almost like blocks? I don't know how they do that, because this is meant to be the lining of the tunnel. So without some kind of form, like some kind of formwork or something like that, which you won't have because you're not in a tunnel yet, you're operating in the ground. I'm not too sure how they exactly do that. And I would go as far as to say as it would be extremely difficult.
These are filled with suitable construction material, so that blocks can be cast side by side to create a permanent, continuous structure. In this way, 3D structures are built step by step and block by block in the ground.
Now, I'm not doubting that you could build blocks of essentially concrete in the ground, but determining how strong that particular block is, given that ground conditions vary considerably, even just 10 meters from one location to another, you would have to inject litres and litres of grout through each hole. We're talking maybe 150 litres of grout in each individual hole minimum, just to build a single block, and then you probably have to then inject grout behind that in order to stabilise that. So it's going to be a very, very thick lining, extremely thick.
The spoil is disrupted, allowing the geology within the tunnel
I mean, this bit kind of blows my mind.
to be removed easily using our drip.
So the way, so they've formed the lining. Let's assume the lining's not exactly perfectly level, which it's not going to be, either at the top of the tunnel or the bottom, essentially the road deck. So how do you then remove all this spoil? Well, you have this kind of, it looks a bit like a road header with like some kind of shovel plate on the front that kind of collects the material, and then it looks like it's spraying it down so as it kind of chews through it. But this is not going to be as easy as they make it out to be, because first of all, the lining of the tunnel's not going to be even. I think it's not going to be even. That's what I could be convinced, but I don't think it will be even. Neither the sides nor the front. So the actual machine that goes through the tunnel will not remove all the material. And secondly, that this material kind of falls away almost. I'm assuming they use some kind of explosives in the horizontal kind of wells that they've created, and then they blow it out, as it were. Maybe I'm wrong there, but this kind of machine, similar to a road header, could theoretically be limited to 70, 80 meters per day. Just a point of kind of thought.
And shield technology, we can safely remove the spoil away from the work site. The tunnel wall.
I mean, look at the tunnel walls. Look how smooth and perfect they look. How would you do that without using formwork and using grouting? I would think that you would have to then insert some kind of temporary form in the tunnel after you'd excavated the material, and then inject grout again to form kind of a secondary lining, or use precast concrete segments like today, and then install them in the kind of half-finished tunnel.
Are prepared for final use, leaving a smart structure that can be monitored and maintained throughout its life.
Tunnels are everywhere. Whether you pass through one on foot, in a car, on a train, or even on a cruise ship, there's a few different ways they can be built. We still rely on techniques that were pioneered centuries ago, and even those fancy machines used on the biggest projects have been around for decades. But this new take on tunnelling is unlike anything we've seen before, because all the work is carried out by swarms of robots. Yes, really, and it actually works. And that's not all. 3D printing, autonomous vehicles, digital twins, it's a system that's about as high-tech as you can get, and there are some big partnerships already in place. Now, you might already have an idea in your head about how this robot tunnel works, but you'd probably be wrong.
Conventionally, you dig a hole and then build the tunnel as quickly as you can behind your excavation process to hold that tunnel open. What we do is we actually build the tunnel in the ground.
I mean, just look at that. That must be formed by some kind of explosion. There's no other way. The issue with that is that lots of communities don't want you using explosives, and obviously the regulators as well. So That, I mean, I'm not against using explosives to create tunnels, but I'm just kind of highlighting the fact that, in fact, I would promote the use of explosives to make tunnels, but I'm just pointing out that the fact that regulators and just the general community are a bit apprehensive about that kind of approach being used.
First, and then empty it afterwards. So it's literally turning the process on its head.
Confused? Well, we'll break it down for you. The process starts by drilling holes in the middle of the target area and around the spot where you want to build, which are filled with special bore pipes. Samples of the soil are used to create a digital twin, which is like a virtual blueprint of the structure packed with data that's then fed to the army of robots. Once this is done, the robots are placed inside the pipes where they begin constructing the shell of the tunnel. They do this first by drilling a number of access points along the length of the pipe. These are used to inject a kind of composite material into the earth, which hardens to...
See how these spheres of grout are formed? There's no way you could form like a square shape unless you had hundreds of thousands of access points and you're injecting very, very small, 300, 400 milliliters of grout here and here, there, and then you use that to form a frame. But even then, it would not result in a flat surface. It would be quite uneven and jagged.
Segments of the tunnel lining. Tiny robotic cutting arms then carve chambers between these areas of material, which are filled with more of it, creating a continuous structure.
We actually put very small amounts in, like 3D printing, so that we build up a structure with lots of small amounts. You build the structure up using...
See, that is a better representation of what it will look like internally and externally. Lots of little bubble spheres. Now, I'm not saying that's a bad thing. Absolutely not. That's a perfectly good, structure to kind of ensure the structural integrity of your tunnel. But it's not going to look like how it did in that previous render.
Geology,
unless you line it internally with some other solution, either precast or you create some kind of form and then you inject grout either internally or from these external bore pipes
to support the build. So we can put our building blocks, if you like, anywhere we like within the geology because it will stay there, and then you gradually fill in the gaps.
Because the robots can pass each other inside the pipes, you can have many of them working all at once. And we really are talking about an actual swarm of robots here.
We have absolutely no problem putting up to 5,000 or 10,000 of these robots into a system. Now that's 5 or even 10,000 cubic meters of material built every 24 hours. There's absolutely no way that can be achieved other than by a swarming process.
Once the structure is complete, drills are brought back in to disrupt the soil, which is then removed.
See, they're saying drills disrupt the soil, not explosives. I might have been wrong there, but the way it kind of is visualized there, it looks like it's being exploded from inside. So I'd be very keen to learn how that process works of disrupting the soil. If you're not using explosives, it kind of looks like it just crumbles. But what would happen if that strata was kind of a combination of like gravel and clay and various other, very loose sandstone? I'm not sure, or kind of very wet material, how that would crumble in that way, and then how would you then remove that quickly without using a TBM? I mean, you could remove it, but I don't think it would be a quick process.
By autonomous vehicles, leaving behind a ready-made tunnel. Then, other than a bit of final preparation to the walls and of course the laying of the road or rail line, the tunnel is ready to go, and those bore pipes can even be reused for maintenance. This could enable tunnels to be built up to 10 times faster and at half the cost of conventional methods. In October 2022, HyperTunnel unveiled Peak 15, its first structure built entirely by those robots, constructed at its UK R&D facility. Yes, it was only 6...
Now, this is how I visualized it when I originally watched the first kind of CGI video. As accurate as you can get it, there's going to be jagged edges, there's going to be kind of pits where bits aren't quite grouted enough, and when you excavate they fall in. So you end up with a very non kind of level tunnel. It's very kind of rough, and then you've got to run a machine through it. I mean, potentially, you know, it could collide with the edges, so you'd want to make that machine smaller than it is, and then you'd have to run something else through the tunnel to kind of mop up the bits that it's missed, in my opinion, unless the accuracy of this grouting can be improved considerably. I mean, to be fair, this is the first go, so maybe they can make it, some parts of it look reasonably decent, so maybe it again, it also depends on the strata. If the strata is quite poor, you might end up with more jagged edges, you might end up with more kind of pits forming in the tunnel lining.
Wide, making it just about big enough for pedestrians. Only a few robots were used rather than thousands, it was technically built above rather than below ground, and the results were a little rougher than in those fancy renderings. But it showed that the basics of the approach do work, and with a little more fine-tuning it could be ready to go for real in the not too distant future. What's also interesting is who it was built for, Network Rail, which owns and manages most of the UK's rail network. It's responsible for maintaining tunnels all over the country, including hundreds that were constructed over a century ago. Many of these now need to be repaired or enlarged, and Network Rail has been looking for new ways of doing this that are safer and less disruptive. After the project finished, Network Rail said that Peak 15 moves us a step closer to that goal. So it's being taken seriously.
So in reality, what they're saying is that this technology is probably 5 years away from kind of being commercially viable, in my opinion, from that statement.
There's clearly a lot of potential with this tech, and Steve thinks we might start seeing some...
Very interesting that they've shown this image of underground kind of more autonomous vehicles. Looks very similar to the Boring Company, doesn't it? In a very interesting kind of way. It might be touting their business to a potential client there.
Innovations in other areas of construction pretty soon.
By the end of this decade, I believe that underground construction will be dominated by swarm robotics. Now, I expect us to have a very large part of that, of course, and I think it will be even beyond what we can imagine today.
Whether HyperTunnel can really go from this to this, and how long that will take, are questions that can't be answered yet.
It's a bold statement, but I like it when a CEO comes out and says things like that. The kind of the bones of the technology are good. I like the fundamentals, but the execution is the hard bit, as we know. Renders are easy, production is hard.
But the company is definitely on an exciting path, and it seems to have some light at the end of its R&D tunnel.
Okay, I think we'll finish on that one. I like the company. I like the fact it's based in the UK. Certainly, that's interesting to me. And I think the overall idea will work, but it might not exactly correspond to those renders that we've seen. But there are definitely some good use cases for this technology. More specifically, enlarging existing tunnels, or possibly constructing tunnels in areas not suited to TBMs, maybe shorter tunnels of sub 900 meters, that kind of thing. It'd be interesting to see how well it goes around corners as well with the horizontal drilling. There's a lot of unanswered questions, but I think that this idea is definitely worth pursuing. It's definitely not vaporware. We're definitely going to see this kind of come into larger civils projects in the next sort of 3 to 4 years. And I'm interested to see it, and I wish the company well. Hopefully we can follow the news regarding this company in the future, and that'll be an interesting thing to include on this channel. Hope you enjoyed that video. I'm not trying to be too critical. I'm just kind of thinking out loud, and I hope that people appreciate that. If you enjoyed this video, please like it. If you've not already done so, please subscribe to the channel. Please consider following us on Discord, Twitter, and supporting me on Patreon if you'd like to do so. Yeah, put your comments below. Do you think this technology has got, the legs to go far? Do you think that it's a competitor for the Boeing company? Do you think they might even partner up with the Boeing company one day to do short lengths of tunnel in between Boeing company tunnels? What do you think? Okay, guys, hope you enjoyed that. Have a nice evening, and good night, and do not be boring. Take care now.
And with artificial intelligence, we are summoning a demon.
Come get some.